Guys, welcome back. So the next question is, how can outlier values be treated? So how we can treat the outlier values? So an outlier is a data point that is distance from other similar points. Okay, that is different from other similar points. They may be due to variability in the measurement or may indicate experimental errors. So if possible, outliers should be excluded from the data set. However, detecting that anomalous instances might be very difficult and it's not always possible. So there are some methods we can apply them in practice to treat the outliers. So the three different methods to deal with outliers is the first one is univariate method. This method looks for data points with extreme values on one variable. Then we have multivariate method. We look for unusual combinations of all the variables. Then we have Minkowski error, which reduces the contribution of potential outliers in the training process. So the univariate method is the one of the simplest methods for detecting outliers. So we can use the box plot. So the box plot is a graphical display for describing the distributions of the data. Box plot use the median and the lower and upper quartiles. The maximum distance to the center of the data that is going to be allowed is called cleaning parameter. If the cleaning parameter is extensive, the test becomes less sensitive to outliers. On the contrary, if it is too small, then many values are detected as outliers. The second one is multivariate method. Outliers do not need to be extreme values. Indeed, as we have seen with different points, the univariate method does not always work well. The multivariate method tries to solve the problem by building a predictive model using all the data available and cleaning those instances with errors above a given value. So when modeling, it is important to clean the data sample to ensure that the observations represent the problem. So an outlier is an observation that is unlike the other observations. So generally, outliers are the samples that are exceptionally far from the mainstream of the data. So if we know the distribution of values in the sample is Gaussian, we can use the standard deviation for identifying the outliers. For example, within one standard deviation of the mean will cover 68% of the data. So if the mean is 50 and the standard deviation is 5, as in the test data set, then all data in the sample between 45 and 55 will account for about 68% of the data sample. We can cover more of the data sample if we expand the range as standard deviation from the mean to 68%. standard deviations from the mean to 95%, standard deviations from the mean 99.7%. All right. So this is how we can treat the outliers. So you can drop outliers only if it's a garbage value. If you cannot drop outliers, then we can try a different model. Data detected as outliers by linear models can be fit by nonlinear models. Therefore, be sure you are choosing the correct model. Next is, how can we calculate accuracy using a confusion matrix? So confusion matrix is a very, very important concept in machine learning or in data science. So it's used to predict the accuracy of the classification model. So it's an n by n matrix for evaluating the performance of a classification model, where n is the number of target classes. The matrix compares the actual target values with those predicted by the machine learning model. This gives us a holistic view of how well the classification model is performing and what kinds of errors it is making. So you can see in the confusion matrix, there are some elements like true positive, false positive, true negative, false negative. So, and you can also see actual and predicted. So when actual is positive and if predicted is also positive, then it's known as true positive. It's a proper classification. When actual is negative and predicted is also negative, then it's a true negative, which is also a proper classification. But if the actual is negative and the predicted is positive, then it's known as a false positive, which is a misclassification. Again, if actual is positive and predicted is negative, then again it's a false negative, which is again a misclassification. So the target variable has two values, positive or negative. The columns represent the actual values of the target variable. The rows represent the predicted values of the target variable. So once you find out the true positive, true negative, false positive, and false negative, then we can find out the different parameters. So to calculate the accuracy, the formula is, you can see on the screen, true positive plus true negative divided by total observations. So accuracy is what? How much the classification is correct. So it is the summation of true positive and true negative divided by total observations. Okay. So if the total observations are, for example, 650 and the true positive are 262 and true negative are 347, then sum the TP and TN, which becomes 609 divided by 650, which is 93% of accuracy. Okay. So this is how we find out accuracy in the confusion matrix. So for detailed information, you can try out understanding more about confusion matrix. All right. We have other parameters like precision, recall. So we will see them later. So people who bought also brought something. Recommendations seen on Amazon are a result of which algorithm? So these are purely recommendation engine. So the recommendation engine is accomplished with collaborative filtering. Collaborative filtering explains the behavior of other users and their purchase history in terms of ratings, selection, etc. So we often see this when we purchase something on Amazon, right? So it's purely the recommendation concept so that we don't have to miss out the similar items. All right. Then what is recommender systems? Okay. So recommender system is a subclass of information filtering techniques. It helps us to predict the preferences or ratings which are which users are likely to give to a product. So the recommendation systems are everywhere now, in YouTube, in Instagram, in Netflix, in Facebook, in Prime Video, in Amazon. All right, it's in everywhere. So recommendation systems are an important class of machine learning algorithms that offer relevant suggestions to users. So they are categorized as either collaborative filtering or a content-based system. So how does the YouTube know what videos you will watch? How does Google always seem to know what news you will read? So they use a machine learning technique called recommender systems. Practically, recommender systems encompass a class of techniques and algorithms which are able to suggest relevant items to the users. Ideally, the suggested items are as relevant to the user as possible so that the user can engage with those items. YouTube videos, news articles, online products, and so on. Items are ranked according to their relevancy, and the most relevant ones are shown to the user. The relevancy is something that the recommender system must determine and is mainly based on historical data. If you have recently watched YouTube videos about elephants, then YouTube is going to start showing you a lot of elephant videos with similar titles and themes. So recommender systems are generally divided into two main categories. One is collaborative and the other one is content-based systems. So the collaborative filtering methods for recommender systems are the methods that are solely based on the past interactions between users and the target systems. Thus, the input to a collaborative filtering will be all historical data of user interactions with target items. This data is typically stored in a matrix where the rows are the users and the columns are the items. So the collaborative filtering works for predicting users' rating of four things: an image, book, video game. So based on the user's historical data, the likes and dislikes of each item, the system tries to predict how the user would rate a new item, which they have not rated yet. So this was about collaborative. Then in contrast to it, the content-based approaches will use additional information about the user or items to make predictions. For example, in the many places, the content-based system might consider the age, gender, occupation, and other personal information about the users when making the predictions. It's much easier to predict that the person would not like the video if we knew that it was about skateboarding, but the user's age is 87. Okay, so this was about recommender systems. Next, name three disadvantages of using a linear model. So, the assumption of linearity of the errors. You cannot use this model for binary or count outcomes. There are plenty of overfitting problems that it can solve. It cannot solve. So these are the disadvantages of using a linear model. And what's the need to perform resampling? So see the question, what is the need to perform resampling? So we will have to understand what's resampling. So resampling is a methodology of economically using a data sample to improve the accuracy and quantify the uncertainty of a population parameter. So while reading about machine learning and data science, we often come across a term called imbalanced class distribution, which happens when observations in one of the classes are much higher or lower than any other classes. As machine learning algorithms tend to increase accuracy by reducing the error, they do not consider the class distribution. This problem is prevalent in examples such as fraud detection, anomaly detection, facial recognition, etc. So the common methods for resampling can be cross-validation or bootstrapping. So cross-validation is used to estimate the test error associated with a model to evaluate its performance. So this is about resampling. Then list out the libraries in Python used for data analysis and scientific computations. So you can see the list of libraries for data analysis and scientific computations. So the most popular libraries are listed out. So Python, since it's a general purpose language and is often used for things other than data analysis and data science, makes Python extremely useful for working with data. So the first one is NumPy and SciPy. NumPy stands for numerical Python. The most powerful feature of NumPy is n-dimensional array. This library also contains basic linear algebra functions, Fourier transforms, advanced random number capabilities, and tools for integration with other low-level languages like Fortran, C, and C++. SciPy stands for Scientific Python. It is built on NumPy. SciPy is one of the most useful library for a variety of high-level science and engineering modules like discrete Fourier transform, linear algebra, optimization, and sparse matrix. Then we have pandas. Pandas means panel data for structured data operations and manipulations. It is extensively used for data munging and preparation. Pandas were added relatively recently to Python and have been instrumental in boosting Python's usage in data scientist community. Then we have Matplotlib, which is a visualization platform. Matplotlib for plotting variety of graphs starting from histograms to line plots to heat plots. We can use PyLab feature in IPython notebook to use these plotting features inline. If you ignore the inline option, then PyLab converts IPython environment to an environment very similar to MATLAB. Then we have scikit-learn. Scikit-learn for machine learning, built on NumPy, SciPy, and Matplotlib. This library contains a lot of efficient tools for machine learning and statistical modeling, including classification, regression, clustering, and dimensional reduction. So finally, Seaborn for statistical data visualization. Seaborn for statistical data visualization is a library for making attractive and informative statistical graphics in Python. It is based on Matplotlib. Seaborn aims to make visualization a central part of exploring and understanding the data. Then, what is power analysis? So, power analysis is a integral part of the experimental design. It helps you to determine the sample size required to find out the effect of a given size from a cause with a specific level of assurance. Power analysis is directly related to tests of hypotheses. While conducting tests of hypotheses, the researcher can use the feature of power analysis, okay, to explain collaborative filtering. So we have seen this already. So what is bias? So bias is a very important term. Bias is an error introduced in your model because of the oversimplification of a machine learning algorithm. It can lead to underfitting. So bias is taken to mean interference. So we have different types of bias, all right, and we have to understand what are the types of bias and what are the source of bias. So the huge success of machine learning applications in the past decade has inspired its adoption in domains such as social justice, employment screening, and in smart interactive interfaces such as Siri, Alexa, and the like. So, and when the things happen, there will be some problems associated with this. So, bias is a type of error in which certain elements of a data set are more heavily weighted than others. A biased data set does not accurately represent a model's use case, resulting in skewed outcomes, low accuracy levels, and analytical errors. In general, training data for machine learning projects has to be representative of the real world. This is important because this data is how the machine learns to do its job. Data bias can occur in a range of areas, from human reporting and selection bias to algorithmic and interpretation bias. So we have different types of bias like sample bias, which occurs when a data set does not reflect the realities of the environment in which a model will run. We have exclusion bias, which is the most common at data pre-processing stage. Most often, it's a case of deleting valuable data thought to be unimportant. It can also occur due to the systematic exclusion of certain information. Then we have measurement bias. This type of bias occurs when the data collected for training differs from that collected in the real world, or when faulty measurements result in a data distortion. A good example of this bias occurs in image recognition datasets, where the training data is collected with one type of camera, but the production data is collected with a different camera. Then we have recall bias, observer bias, racial bias, association bias, all those things. So this is about bias in machine learning, data science, and other fields. All right. So just practice these. If you have any queries, you can write to us. All right. Thank you.